The Burj Khalifa. Just the name conjures up images of incredible height and breathtaking views. Soaring over Dubai at a staggering 2,717 feet, it stands as the tallest structure ever built by humans. Its sleek spire-like design has become a global icon, a symbol of human ingenuity and ambition. But the Burj Khalifa is more than just a building. It represents our age-old fascination with reaching for the sky, a testament to our relentless pursuit of pushing the boundaries of what's possible. This incredible structure prompts us to ask, how high can we actually build? What are the limits of our engineering capabilities, and what drives us to keep reaching for the clouds? The Burj Khalifa's story is one of innovation, determination, and the boundless possibilities of human imagination. It is a story that has captivated the world and left us wondering just how high we can truly reach. The desire to build tall is nothing new. For as long as humans have walked the earth, we have looked up at the sky with wonder and ambition, dreaming of structures that could pierce the clouds and stand as monuments to our ingenuity. This longing to reach higher, to defy gravity and the limitations of our environment, is woven into the very fabric of our history. It is a story of visionaries, of communities coming together, and of relentless innovation. Throughout history, humans have attempted to touch the heavens with their creations. Whether for spiritual, political, or practical reasons, the act of building upward has always been a symbol of aspiration. From the earliest civilizations, people have gazed up at towering monuments, feeling both awe and inspiration. These structures were not just feats of engineering, they were statements of intent, declarations that humanity would not be bound by the earth alone. From the ancient pyramids of Egypt, which rose from the desert sands as both tombs and testaments to the power of the pharaohs, we see the beginnings of this age-old pursuit. The Great Pyramid of Giza, for thousands of years, held the title of the tallest man-made structure on Earth. Its construction required not only immense labor and resources, but also a deep understanding of mathematics and astronomy. The pyramids were more than just burial sites, they were a bridge between the earth and the sky, a way for ancient Egyptians to connect with the divine. To the medieval cathedrals of Europe, towering structures have always been symbols of power, faith, and cultural achievement. The soaring spires and intricate stonework of cathedrals like Notre Dame and Cologne were designed to inspire awe, drawing the eyes and the spirits of worshippers upward. These buildings were marvels of their time, pushing the boundaries of what was possible with stone and mortar. They were built not only to honor the heavens, but to demonstrate the skill and devotion of those who constructed them. These early attempts at reaching for the sky were limited by the materials and technology available at the time. Builders relied on stone, mud brick, and wood, using ingenious methods to stack, balance, and reinforce their creations. The process was slow and labor-intensive, often taking decades or even centuries to complete a single structure. Yet, despite these challenges, each generation pushed a little higher, learning from the successes and failures of those who came before. However, they laid the groundwork for the architectural marvels that would follow. The ruins of these ancient buildings still stand today, reminders of humanity's enduring quest to build upward. As cities grew and societies evolved, so too did our ambitions. The lessons learned from ancient construction techniques informed the innovations of later eras, creating a continuous thread of progress that connects the past to the present. The invention of new materials like steel and reinforced concrete in the 19th century revolutionized construction. Suddenly it was possible to build taller, stronger, and faster than ever before. The Industrial Revolution brought with it not just new materials, but new ways of thinking about architecture and engineering. Buildings could now rise above the limitations of stone and wood, reaching heights that would have been unimaginable to previous generations. This paved the way for the first skyscrapers to rise in cities like Chicago and New York. These early giants transformed the urban landscape, creating skylines that became symbols of progress and modernity. The race to build higher was on, with architects and engineers competing to see who could push the limits of design and technology. Skyscrapers became the new cathedrals, monuments not to gods but to human achievement and ambition. These early skyscrapers, while impressive for their time, were merely stepping stones on the path to true architectural heights. Each new building set a precedent, inspiring others to dream even bigger. The Flatiron Building, the Woolworth Building, and the Empire State Building all captured the imagination of the world, becoming icons of their era. They represented not just technical prowess but the spirit of a society determined to rise above its circumstances. With each new technological advancement, humans inched closer to the clouds, driven by a desire to leave their mark on the world and test the limits of their own capabilities. The skyline became a canvas for innovation, with each new tower a brushstroke in the ongoing masterpiece of human achievement. Today, skyscrapers are not just places to live or work, they are symbols of hope, ambition, and the relentless pursuit of progress. The Burj Khalifa stands as the current pinnacle of this ongoing pursuit, a testament to our insatiable desire to reach for the sky. Soaring over 2,700 feet above the desert, it is more than just a building. It is a symbol of what humanity can achieve when we dare to dream big. Yet, even as we marvel at its height, we know that the story does not end here. The quest to reach higher continues, fueled by the same spirit that inspired the builders of the pyramids and the architects of the cathedrals. As long as there are dreams to chase and horizons to expand, humanity will keep reaching for the sky. The construction of the Burj Khalifa was an unprecedented feat of engineering, pushing the boundaries of what was thought possible. Rising from the desert sands of Dubai, this iconic structure was not just about reaching new heights, but about redefining what humanity could achieve when vision, ambition, and technology come together. The project began as a bold idea, a dream to create the tallest building the world had ever seen, and quickly evolved into a global symbol of innovation and determination. Every step of the way, the team faced daunting technical challenges that had never been encountered before. From the drawing board to the construction site, engineers and architects had to invent new methods and materials to deal with the extreme forces at play at such heights. Wind, temperature, and gravity all posed unique threats to the stability and safety of the structure. To overcome these obstacles, the team relied on cutting-edge computer simulations, rigorous testing, and a relentless commitment to problem-solving. The solutions they developed would go on to influence skyscraper design around the world. One of the most significant breakthroughs was the building's unique Y-shaped footprint. This innovative design was not chosen for aesthetics alone. It was meticulously engineered to reduce wind loads and provide greater stability to the tower. By distributing the building's mass and allowing wind to flow more smoothly around the structure, the Y-shape minimized the dangerous swaying that can occur in super tall buildings. This approach set a new standard for skyscraper design, demonstrating how form and function can work hand in hand to solve complex engineering problems. The building's exterior is clad in over 28,000 glass panels, each one specially engineered to withstand the harshest conditions Dubai could throw at them. These panels were designed to reflect the intense desert sun, reduce heat gain, and resist the abrasive effects of sand and wind. The installation process itself was a marvel of precision, requiring teams of skilled workers to fit each panel perfectly into place, hundreds of meters above the ground. The result is a shimmering facade that not only protects the building, but also gives the Burj Khalifa its iconic, gleaming appearance. To construct a building of such immense height, even the concrete had to be reimagined. Traditional concrete would not suffice, so a special high-density, low-permeability mix was developed to ensure strength and durability. Innovative pumping techniques were used to transport this concrete to unprecedented heights, sometimes over 600 meters above the ground. This process required not only advanced machinery but also careful coordination and timing, as the concrete had to be poured and set with absolute precision to maintain the building's structural integrity. Beneath the Burj Khalifa lies a foundation as impressive as the tower itself. The building rests on a massive concrete raft, which is in turn supported by more than 192 piles driven deep into the earth. These piles anchor the structure, distributing its immense weight and ensuring stability even in the shifting sands of Dubai. The foundation work required meticulous planning, advanced geotechnical analysis, and months of labor, all to create a base strong enough to support the world's tallest building. The Burj Khalifa is not just a marvel of height, it is a testament to the incredible ingenuity, perseverance, and collaboration of thousands of people from around the world. Engineers, architects, and construction workers, each brought their unique expertise and passion to the project, working together to turn an audacious dream into a breathtaking reality. Their achievement stands as a symbol of what humanity can accomplish when we dare to dream big, embrace challenges, and unite in pursuit of the impossible. To truly appreciate the magnitude of the Burj Khalifa, it's essential to place it within the historical context of tall building construction. The story of the Burj Khalifa is not just about a single building, but about humanity's ongoing quest to reach ever higher, to push the boundaries of what is possible, and to redefine the limits of architectural ambition. Throughout history, each generation has sought to leave its mark on the skyline, and the Burj Khalifa stands as the latest, and perhaps boldest, chapter in this ongoing saga. Before the Burj Khalifa claimed the title of tallest, the honor belonged to Taipei 101 in Taiwan, which held the record from 2004 to 2010. Taipei 101 was a marvel in its own right, designed to withstand typhoons and earthquakes, and it became a symbol of Taiwan's economic growth and technological prowess. Its unique design, inspired by traditional pagodas, blended cultural heritage with cutting-edge engineering, making it a source of national pride and a global icon. Before Taipei 101, the Petronas Towers in Malaysia reigned supreme for 6 years. These twin towers, with their striking sky bridge and Islamic-inspired motifs, were more than just office buildings. They were a statement of Malaysia's aspirations on the world stage. The Petronas Towers not only transformed Kuala Lumpur's skyline but also set new standards for skyscraper design and construction in the late 20th century. Looking further back, we see iconic structures like the Empire State Building in New York City, which held the title for over 40 years. Completed during the Great Depression, the Empire State Building became a symbol of hope, resilience, and American ingenuity. For decades, it was the benchmark against which all other skyscrapers were measured, and it remains one of the most recognizable buildings in the world. And the Chrysler Building, a symbol of Art Deco architecture and ambition, briefly held the title of world's tallest before being surpassed by the Empire State Building. Its gleaming spire and intricate ornamentation captured the spirit of the Roaring Twenties, reflecting both the optimism and the competitive drive of its era. Each of these buildings represented a significant leap forward in construction technology and design. They were not just feats of engineering but also cultural milestones, symbols of their city's ambitions and the technological progress of their times. The race to build higher has always been about more than just height. It's about innovation, national pride, and the desire to inspire future generations. However, the Burj Khalifa surpasses them all, more than doubling the height of the Empire State Building. Its sheer scale is almost unimaginable, rising to a height that would have seemed impossible just a few decades ago. The Burj Khalifa is not only the tallest building in the world, but also a symbol of Dubai's rapid transformation from a desert outpost to a global metropolis. It dwarfs even the Petronas Towers, making previous record holders look modest by comparison. The Burj Khalifa's height is so extreme that it required entirely new approaches to engineering, materials, and construction logistics. Its presence on the skyline is a constant reminder of how far human ingenuity can go when vision and resources align. This dramatic increase in height is a testament to the rapid advancements in engineering and construction techniques over the past few decades. From wind-resistant designs to high-strength concrete and innovative elevator systems, each new skyscraper builds on the lessons of its predecessors. The Burj Khalifa stands as a beacon of what is possible when ambition, technology, and creativity come together, and it challenges us to imagine what the next chapter in the story of tall buildings might look like. While the Burj Khalifa stands as a testament to human achievement, it also begs the question, how much higher can we go? Building taller comes with its own set of challenges. As buildings climb higher, they face increasingly strong winds, putting immense stress on the structure. The weight of the building itself becomes a major factor, requiring innovative designs and materials to distribute the load and maintain stability. Another significant challenge is the transportation of materials and people. Elevators need to travel farther and faster, requiring new technologies and energy-efficient solutions. Additionally, the availability of suitable building materials that are both strong and lightweight becomes crucial at extreme heights. Overcoming these limitations will require continued innovation in materials science, structural engineering, and construction techniques.